Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now, many of the types of applications that you'll build as a C# developer will require you to work with text, whether you're formatting the text for display to the end user or whether you're manipulating the text in some way. Like a good example would be whenever you are massaging data. And that's a term that developers use to talk about taking data from a file or a database and it's in some raw form and you need to manipulate it. You need to remove certain characters, you need to add certain characters in certain positions in order to get it and prepare it for ingestion, to be used by some other software system or to be saved in a different file format, whatever the case might be. So manipulating data is a key skill, whether for display or for the sake of massaging data into the right format. Furthermore, whenever you're working with the string data type, you're working with a data type that can hold a lot of information. So to extend the bucket analogy, you're working with a really big bucket. And when you're working with big buckets, you have the responsibility of working with them in an efficient way, because when you're working with data that takes up a lot of memory, it requires a lot of processing power. You are putting a strain on system resources. Now, admittedly, it would take a lot of string manipulation to slow down a computer, especially a modern computer. However, as software developers, we want to do things efficiently, and so it's important to understand that there are tools in the .NET Framework class library that will help us work with and manipulate strings in a very efficient way. So that's really the purpose of this lesson, to show you how to perform some simple string manipulations, like inserting special characters into your literal strings, formatting strings, especially numbers and dates and things of that nature, manipulating strings, changing things about strings, searching for items and removing them or replacing them with something else in strings, and then also working with strings in a more efficient way. So as you can see, I've already taken the liberty of setting up a new console window project called Working with Strings. Please take a moment, pause the video, and catch up with me. And I've already added 3 lines of code that we'll use to demonstrate some key manipulations for our strings. And so what I'll wind up doing is just typing in a string and then showing you some manipulation and then moving on to the next line. But at any rate, let's go ahead and start by talking about the special nature of the backslash character, which is that character there. I always used to get my characters confused. That's forward slash, that's backslash, okay? So a backslash character can be used to escape or insert escape sequences into literal strings. This will allow us to do things like put special characters, insert line feeds, and things into a literal string. So for a good example of this, what if I wanted to type something ironic like my so-called life, right? And I wanted to insert a series of double quotes around the word so-called so that it displays the way that I would, as the author of this, expect it to be displayed on screen. Now, unfortunately, you can see that the Visual Studio, on behalf of the C# compiler, doesn't like this at all. It thinks that you have 2 literal strings here, the word my and life, and in between something that it can make no sense of whatsoever, the word so, or the term so, a minus symbol, and then the word called. These are not variables that have been declared. It doesn't recognize them as keywords. So C# does not like this. In order to insert a special character like a double quote to say, I don't want this to delineate a literal string, I want to use this inside of my literal string, I'll use the backslash character before each double quote, which escapes out the double quote and makes it available for use inside of the literal string itself. So now when we run the application, we can get double quotes inside of our string. Okay? Now, similarly, let's go ahead and my string equals, and I tell you what, I'm just going to copy this to my clipboard so I can keep using it. All right, so now what if I needed to add a new line? So what if I need a new line, and I want to split this up onto two separate lines in my application. What I can do is insert a new line character. So think of a line feed /n will create a line feed. And let's go ahead and run the application, and you can see that it's smart enough to know that even though we didn't separate with spaces around the word in new, it was still able to find that escape character for the line feed and represent it correctly in our literal string. All right. Now you might say, well, that's all well and good, but what if I need to actually use the / character? So, for example, in an instruction to go to your C:/drive, and you'll notice that we get a red squiggly line underneath the / because it's expecting us to use the / as an escape character, as an escape sequence, but we've given it nothing after that to indicate which escape sequence we want to use. So in this case we have two options. In fact, in all these cases we have two options. We can use another / character to escape out of it to represent this correctly. So now you can see that you should go to your C:/drive. Or what we can do, and I'll just do this again, go to your C drive. So what we can do is add a @ symbol in front of the literal string, and that tells C# that we want to use our / characters as true / characters, not as escape sequences, all right, or special characters. All right, so let's move on from there. And we've already talked about the use of string.format, and we showed how we could do something like this, where we are going to insert the words first and second into this template, and the template contains a number of replacement codes. And the number inside the replacement code corresponds to which argument is passed in to the string.format as input parameters. So let's run the application, and we would get what you might expect, first equals second. What I didn't tell you at the time was that you can actually reuse the replacement code multiple times, like so, or you can use them in a different order if you like. Whoops, let's go back and change up the order, where the second will be the first item displayed and the first will be the second item displayed, like so. All right. Furthermore, the replacement code has some special powers, and for example, if we want to do a string.format and say, for example, that we wanted to display currency to the end user. So I want to display $123.45 to my end user. Now, in my case, since my computer's culture is set to English US, this will be represented as dollars and cents. But if your culture is, if your country and culture codes are set to, for example, English UK or some other language and some other culture, you would probably see something different whenever you choose to do this. You'll see your native country and culture's symbols for currency. But to create and format values for currency, you use the colon and then C immediately after the numeric replacement code. So in this case, I'm using, say, 0 still represents the first item in the list, but the colon C says I want you to format it like currency, all right? So that when we run it, at least on my computer, you'll see dollars and cents, okay, with the dollar symbol. Now there's all sorts of these little variations on this. So for example, what if I wanted to just display a really long number to an end user, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and I want it to look like a number, not just like how I have it here, where you can't really tell, is that what, 12 billion or 123 million or what? To remove the confusion, what you can do is use the :n format character. And this will add in decimal points and commas to give you the appropriate formatting for a large number. So 1,234,000,000 and so on. Okay. All right. Furthermore, continuing that same thought, what if we were to go string.format and we wanted to represent a value as a percentage? So what if I wanted to display this as a percent? Let's make sure you get those formatting codes in there. And just to show there's nothing up my sleeve here, let's just call this percentage, like so. And then we will insert a percentage here at this replacement code. Let's go ahead and run the application. And you can see that the percentage is 12.3% in this case. Right. And finally, the last one I'm going to show you, but I'll show you where you can find more information, is how to create a custom format. So for example, in the United States, phone numbers have a very specific way that they're presented. So let's go string.format and let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And I want that displayed like a phone number. So I would use 0, and then I'm going to use pound symbols to represent each digit that I want formatted. So in this case, actually I'm going to use parentheses around the first 3 numbers, because that's usually how an area code in a phone number in the United States is presented. Then a space, then 3 more numbers, then a dash, then 4 more numbers. All right, that's just how phone numbers are presented in the US. So let's go ahead and run the application now, and you can see that it in fact formats that number the way that I would expect. Now let me throw one little monkey wrench in this. What if I were to supply too many extra digits? I added another 1, 2 at the very end, and yet I don't have that accounted for in my formatting. Where will it be presented? Well, as you can see, it pushes out the area code to 5 digits instead of just 3. So the moral of the story there is that the formatting will go from right to left whenever you're using custom pound symbols to create a custom format for a numeric value. So again, the numbers will push their way out, and once you get to the very end, it will just put as many numbers as it can on that very first character and push that formatting out to the left. So just be aware of that. Okay. So the next thing that we want to do is start manipulating strings in a more meaningful way. Up to this point, we've just been formatting strings, but what if I want to actually change some things about the strings themselves? Let me start by providing a little something that we can sink our teeth into and work with. And so I'm going to type in a lyric from a song that I like. All right, and notice that I added, or I left in, an extra space here at the very beginning of the string, and then I left in 2 spaces at the very end of that string. All right, and so let's go my string equals my string, and I think the most important thing you want to realize about when you're working with these data types is that they do have built-in functionality that were provided to us by Microsoft. So, for example, every string has this substring helper method that we can use to just say, hey, I want to start at a specific point and then grab all of the characters within a given range. So I can say, start at position 6 and grab me back everything after position 6. So when I run the application, you can see it starts with the word summer, which is at the 6th position, and grabs everything to the very end of that line. So here is position 1, 2, 3, 4, 5, and 6. So it truncates off the first 6 characters and starts me there, and I'm pulling everything else, giving me a subset of the strings from that point on. But I can also say, go ahead and give me just the next 14 characters after that. So don't give me everything to the very end of that string, just give me the next 14 characters, and so I can isolate just a couple of characters, in this case just 3 words in that string. All right. I can also do something like my string dot, to upper, and that will, actually let me do that, and that will do just what you might think it will. It'll make everything uppercase. Great. What if I wanted to replace one character with a different character? So my string dot replace, and say find every blank space and replace it with a double dash, like so. All right, so now when we run the application, you can see that we get double dashes instead of our spaces. It makes it more obvious that we had some spaces at the beginning and the end. All right. We can also equals my string dot remove, and we can remove a number of characters from our string. So instead of just selecting out the substring of characters, we took 3s, we can actually remove those entirely from the string. And you can see, or I'm sorry, summer we took, it has been removed from the string completely. And also, what if we were to want to actually remove those trailing and preceding spaces? We could use the trim method. So let's do my string equals, first of all, string dot format, and here I'm going to grab the length of the string just to kind of demonstrate this. The before length, so, and then the after length. Okay, and so let's go my string dot length, and then my string dot, we'll call the trim method to strip off all of the extra spaces in the beginning and the end, or I could just choose to trim off only the ending spaces or just the beginning spaces, but I'm going to call the trim method to get rid of it all, and then determine what the length of the string is at that point. So you'll recall that we used the length property whenever we were working with the array to find out how many items were in the array. We can also use the length property on a string to tell us how long the string is. So that's ultimately what we're doing here. Tell me how long the string is before we make any changes to it, and then after we trim off those extra spaces, how long is the string itself. Let's run the application again. And so you can see that the before was 46, the after was 43. We trimmed off 3 spaces. Great. All right, the last thing I want to do is talk about the working with strings in a more efficient sort of way. And for example, let me just type in a really quick code example here. So we'll just do this console, well, actually here, my string plus equals, okay, and hopefully you remember what this operator was for, where we're saying give me whatever the value of a string is and concatenate everything on the right hand side to it. So here we're concatenating on just double dashes and then the current value of I as we loop through 100 times. And we'll merely then just display my string in the console window. Whoops. And let's go ahead and actually get rid of that. And we'll start here with a blank slate. All right, so let's run the application. And the output isn't all that interesting. It's just a printout of numbers with some dashes in there. But what's going on behind the scenes is the more interesting part of this. What happens when you're working with the string data type is that it's called a immutable data type, meaning that you can't just add more values to it. What happens behind the scenes is there's this little dance that the .NET Framework runtime is performing to make it look like you're still working with the original variable myString, so the original bucket. But what it does is it creates a second bucket and it starts copying things over. In this case, it copies the previous value of myString plus any of the new stuff we want to put in there, and it creates this new string in a new bucket, and then it removes the old bucket and it gives the new bucket the name myString. Then we say, let's do it again. In fact, let's do it 100 times, and it has to go through that dance 100 times in order to produce the final result that we're printing then in our console window. And as you can see, that's a very inefficient way, and we're requiring a lot of the runtime, a lot of memory management that might put a drain on the system if we were to do a lot of it. So instead, what we can use is a different data type whenever we're going to manipulate strings in this way, where we're going to do a lot of string concatenation or a lot of string manipulation. We can use something called a string builder. So again, just like I said with the random class from the previous video, this may not make a whole lot of sense at first, but hopefully once I talk about what classes are and how to create new instances of classes, this nomenclature that string builder myString equals new string builder, what is that all doing? We'll talk about that very soon. But just let's create a new string builder class, and then we're going to do something very similar to what we did before, where we will iterate through 100 times, but this time, instead of just doing a simple concatenation, we're going to use an append method, which is a more efficient way to append additional information to this string builder object rather than going through the previous step of forcing the runtime to create all these temporary versions of string. So myString append I, and the result will look identical. But what's going on under the hood is that we're working with strings in a more efficient way. So use the string builder along with the append method of the string builder to work with strings in a very efficient manner. Okay, so we talked about quite a bit in a very short amount of time, how to work with the / character for escaping and inserting escape characters, special characters into our literal strings, how to use string.format. In fact, let me show you this little page here for standard numeric string formats. If you just search for this on bing.com, you'll be able to find this article, and it gives you examples and many other usages for the format that we looked at several examples of here. We looked at several of the built-in helper methods to replace or define subsections or completely remove or actually create two upper or two lower to change the case of strings, and then finally how to work with strings in a more efficient manner. Okay, so now we're going to give the same treatment to dates and times, because you'll again find yourself working with dates and times frequently whenever you're building applications, and there's a lot of similar kind of functionality there as well. We'll see you in that next lesson. Thank you.